Imagine standing beneath the vast expanse of a clear night sky. Above you, stars twinkle like distant beacons, their light traveling across unimaginable distances of space. But there's something more, something invisible, a force that touches us every day, though we can't see it. These are the cosmic rays, high-energy particles streaming toward us from the far reaches of the universe. They travel at nearly the speed of light, carrying energy beyond anything we've ever encountered here on Earth. But here's the kicker: they're not just coming from some distant, unknown corner of space. They're coming from violent, mysterious, and yet to be fully understood sources in the cosmos. Where exactly do these cosmic rays come from? This question has driven scientists to the farthest edges of human knowledge. It's a puzzle that is still being solved, even as we stand on the brink of new discoveries that will change the way we understand the universe itself. To understand the mystery, we need to first grasp what cosmic rays are. They aren't rays at all, but subatomic particles, protons, electrons, and heavier atomic nuclei that are traveling through the cosmos with mind-boggling speed. When these particles hit Earth's atmosphere, they collide with air molecules, creating a cascade of secondary particles in a phenomenon known as a cosmic ray shower. These showers are what researchers detect on the ground, using highly sensitive instruments to measure their energy, direction, and arrival time. Cosmic rays are not a single type of particle. Some are made up of hydrogen nuclei, protons, while others are composed of heavier atoms like iron. What makes them so remarkable is the sheer amount of energy they carry. The most energetic cosmic rays contain more energy than the most powerful particles ever created by particle accelerators on Earth, making them one of the most extreme phenomena in nature. And yet, even as we detect these particles, their source remains elusive. Where do these cosmic rays come from? Supernovae, the explosive deaths of massive stars, have long been considered a prime candidate. In the final moments of a star's life, the explosion can propel particles to incredible speeds, possibly creating the cosmic rays we observe. However, not all cosmic rays fit this theory. The highest energy cosmic rays, those with the most mind-blowing power, seem to come from sources that we can't fully explain. Could they be born in the heart of active galactic nuclei, the energetic centers of galaxies, where supermassive black holes devour matter at an unimaginable rate? Or perhaps these particles originate in the explosive and rare events known as gamma-ray bursts, the most intense explosions in the universe? Some researchers even wonder if there's something even more exotic, some source we haven't discovered yet, hidden deep within the vastness of space. These are not just academic questions. They are fundamental to understanding the nature of the universe itself. The hunt for the sources of cosmic rays isn't just about particles. It's about understanding the forces that shape the cosmos, the most violent and energetic processes that govern everything we know. Every cosmic ray that reaches us is a tiny messenger, carrying with it secrets about the most extreme objects and events in space. To uncover these secrets, we need powerful instruments that can track these cosmic rays and provide us with the data we need to solve the puzzle. The Pierre Auger Observatory, located in Argentina, is one of the largest and most ambitious efforts to understand cosmic rays. This sprawling facility spans over 3,000 square kilometers, with more than 1,600 detectors spread out across the terrain. These detectors are trained to spot the faint signals left behind when cosmic rays interact with the atmosphere. By measuring the secondary particles created in these collisions, scientists can estimate the energy of the original cosmic ray. But it's not just about identifying the energy. It's also about identifying where these rays are coming from, something far more difficult than it sounds. Cosmic rays travel vast distances, and by the time they reach Earth, their paths are often deflected by magnetic fields in space, scattering them in all directions. And yet, despite these challenges, the tools we've developed, space telescopes like Fermi and Hubble, ground-based detectors, and global collaborations, are slowly revealing a clearer picture. The cosmic ray sky is starting to look less like a chaotic mess and more like a map, guiding us to the most extreme and distant objects in the universe. We know that supernovae are one of the most powerful events in the universe. When a massive star explodes in a supernova, it releases an overwhelming amount of energy, potentially accelerating particles to create cosmic rays. For decades, scientists have believed that supernovae were the primary sources of these rays. But the most powerful cosmic rays we detect have energies that are far beyond the capabilities of a supernova. Could these extreme particles come from something even more powerful, active galactic nuclei? At the centers of many galaxies, supermassive black holes reside, pulling in vast amounts of gas, dust, and even light. The energy generated by this process can accelerate particles to unimaginable speeds, and these cosmic rays could be the byproduct of this energetic environment. Perhaps even more mysterious are the gamma ray bursts, short, incredibly intense flashes of gamma radiation that occur in distant galaxies. These bursts are the most energetic explosions in the universe, and some scientists speculate they could be a source of the highest energy cosmic rays we detect. One of the biggest challenges in tracking cosmic rays is their interaction with magnetic fields. Space is full of magnetic fields, both within our own galaxy and between galaxies. As cosmic rays travel across vast distances, these magnetic fields alter their path, deflecting them and making it difficult to trace them back to their exact origins. Imagine trying to follow a particle on a winding, twisting path, only to have it veer off course every time you think you've got a clear line of sight. It's like trying to track a ball in a maze, where the walls keep shifting. This is why detecting the true source of cosmic rays is so complex. However, new developments in technology are helping to overcome these hurdles. By combining data from a range of telescopes that observe different wavelengths of light, radio waves, visible light, gamma rays, and more, scientists can reconstruct the journey of cosmic rays, piecing together the path that these particles have taken across space. It's a painstaking process, but with every new discovery, we get a little bit closer to understanding their origin. The hunt for cosmic rays is about more than just identifying particles. It's about answering the most profound questions of existence. These particles are messengers from the farthest reaches of the universe, traveling across time and space, carrying with them clues about the most violent, powerful, and energetic phenomena we've ever witnessed. The cosmic rays that reach Earth aren't just random accidents of nature. They are part of the larger cosmic story, a story that includes the birth and death of stars, the feeding frenzy of black holes, and the creation of galaxies. By studying these particles, we are unlocking the secrets of the universe, one particle at a time. As we continue to chase these elusive particles, we are reminded of the boundless curiosity that drives us to explore the unknown. In a way, the hunt for cosmic ray sources is a reflection of humanity's greatest instinct: to seek, to discover, and to understand. The particles we study today are more than just tiny specks of matter. They are the keys to the universe's deepest mysteries. And with each discovery, we take one more step toward understanding our place in the cosmos.